Hi, my name is Michael, and my research project is focused on the chemical recycling of plastic waste, and here's why. Mass production of plastics kicked off in the 1950s, and since then it has grown exponentially. We now produce more than 350 million tonnes annually. It wasn't until the 1980s that we started trying to deal with plastic waste in a more sustainable way. We began incinerating it. However, this releases a whole host of hazardous chemicals into the atmosphere if not properly filtered. We needed something better. It was closer to the 1990s by the time we realised that we had to start recycling, although after 30 years of recycling we still only recycle about 10 to 20% of plastic waste we produce. The rest inevitably ends up in landfills and the environment. Nobody knows for sure how much plastic waste has made its way into the ocean, although we have found plastic products and particles in every marine environment we've looked at. That's pretty much all of them. The figure on the right shows the total global plastic production since 1950 in blue. That little green loop at the bottom is how much plastic has been effectively recycled and is still in use today. The green loop is 100 million tonnes of recycled plastic out of a total 8.3 billion tonnes produced. That's 1.2% of material that is effectively recycled. That's a very small number, and here's why. The life of a plastic product begins with the extraction of crude oil from deep underground. The oil is refined into hydrocarbons, which are joined into long chains called polymers, in a process called polymerization. Chemical additives are introduced into the mix that give the material desirable physical properties. The product is then used, discarded, and sent to a recycling facility. If the plastic is mostly free of contamination and it is sorted appropriately, it is essentially heated into a liquid state to be reformed. This process degrades the quality of the plastic by shortening the polymer chains. As such, the new material produced is of a lesser quality, quite often not meeting food safe standards and must be downcycled to a lesser material. For example, PET bottles can be recycled into polyester fabric for clothing. But by that stage, the polymer chains have been broken down so much and so many additives mixed in, it can no longer be recycled and must be sent to landfill. The life of a plastic product, when chemical recycling is introduced, closes the loop to create a life cycle in the true sense of the word. Oil can be extracted from the ground as normal and refined and polymerized. This time, however, once the product is used, the chemical recycling process allows the material to be broken down at an atomic level, giving us the chance to rebuild it and create brand new plastics with all of the qualities of the original virgin material. It works by subjecting the waste plastic to high temperature and pressure in the presence of a catalyst. These three work together to break the polymer chains up completely into their original building blocks. These are called monomers and are the original hydrocarbon building blocks refined from crude oil. Now that we have the building blocks, we can repolymerize them into new polymer chains, and the cycle can repeat. The issue with the emerging technology of chemical recycling is that everyone believes that to make the biggest difference, you have to make the biggest machine. I've come at the problem with a new perspective and have decided to miniaturize this technology down to a local scale. Throughout my conceptual journey, I explored various forms and sizes, playing with how different users might interact with the system. Many possibilities came out with regard to general form, however the vast majority focus on encasing the equipment in a single shell that makes the system easier to understand, with an interactive touchscreen to control it. The three concepts I decided on each have a different setting and a corresponding different size and style. The settings I chose are in a school, in a surf lifesaving or dive club, and in a manufacturing facility. The first system is notably the smallest. It is designed to be placed in a school as a means of both chemically recycling the school's plastic rubbish and teaching the students about plastic, about waste, and about the life cycles of everyday products. It consists of two small units. The one on the right is a fully enclosed plastic shredder that kids can feed their bottles and bags into to create an easy-to-deal-with confetti-like feedstock, which can then be inserted into the depolymerization reactor by an adult and closed. The system can then be controlled by the large touchscreen on the front, which would have an interactive suite of lessons concerning plastic production and waste. The main body of the units can both be constructed of chemically recycled PET, furthering people's understanding of the potential of this system. With a small capacity of only about 10 kilos per batch, it is mainly focused on being an educational tool. The second system is a larger unit that can be placed in any coastal-based club with plenty of members. Much like the earlier concepts, it is a fully enclosed system with a touchscreen on the front for controls that gives the system a decidedly non-industrial look. The larger capacity of 30 kilos per batch is intended to promote community cleanups along the beaches, boardwalks, and even in the reefs. The plastic that is found can then be recycled to make money for the club by selling the resultant oil to manufacturers for new products. It both cleans up the local area and supports the local community financially, while spreading awareness and educating them in the process. The third system is much larger than either of the others, with an increased capacity that makes it suitable to be installed directly into a manufacturing facility. Across the top of this page, you will see all the components that this system requires. Flowing from left to right, any parts will be fed into the shredder, which breaks the plastic down enough to be fed into the extruder. Once melted, compressed, and palletized, the system can be easily inserted into the reactor. This is where the magic happens. The reactor is heated and pressurized and catalysts are introduced. The polymers break down quickly, forming a crude oil type liquid. The lighter gaseous molecules are siphoned off into another unit, which will cool and condense them down into a separate liquid and gas. The heavier crude oil can then be extracted from the reactor for the process to begin again. At 100 kilos per batch, this capacity is designed to handle the incoming waste from any offcuts, mistakes, test runs, and overproduction that the facility might output. Allowing the manufacturer to recycle this plastic directly in-house to then use on a future production run will save them money on both new material and fees to have their bins emptied. A surprising amount of wastage is created at the manufacturing stage, and this system aims to tackle that head-on. Reducing how much waste we create is always going to be the most important tactic. This product is merely a last line of defense for all the plastic that would otherwise slip through the cracks. Thank you.